Question 7. Propane dioic acid. Propane dioic acid. Prop means 3 carbons, ane means single bonds, di means 2, oic acid means it's got 2 carboxylic acid groups. So it's got 3 carbons with single bonds and 2 carboxylic acid groups. Remember, a carboxylic acid group is C double bond O, OH. It's a solid organic solid that's soluble in water. Draw the skeletal form of the propane dioic acid. So for skeletal form, you're going to draw dots or corners on a line for carbons, and you're not going to draw any H's, any C to H's. Any C to H's, you leave the H's off. You have to draw the H's on the OH to show that it's an OH and not just an O. So what do you have? You have 1, 2, 3 carbons, an OH, and a C double bond O. So you've got a C double bond OH and a C double bond OH, and you've got 2 of those, got dioic acid, and 1, 2, 3 carbons. Don't draw any H's on, and the carbons, as I say, are corners on lines or dots. Describe how to prepare 250 centimetre cubed of an aqueous standard solution of propane dioic acid. Remember, it's a solid containing an accurately measured mass of the acid. Include essential practical details for 6 marks. So what do you do first of all? First of all, mention it's a solid. You measure the mass accurately of the solid by putting a weighing bottle or a beaker or a conical flask, it doesn't really matter, you can even just say container, onto a digital balance and press the tare button. The tare button then imagines that the beaker or the container or the weighing bottle isn't there. So then you're only taking 1 measurement rather than 2, and you're going to reduce your percentage error. So put a beaker or a weighing bottle onto a digital balance and press the tare. Use a spatula to add the propane dioic acid. Remember, it's a solid, into the weighing bottle or beaker or flask until the mass is reached. It doesn't tell you what mass you want, so you just say until the mass is reached, until the desired mass, the mass that you want, is reached. Then you add the contents of the weighing bottle into the volumetric flask. A volumetric flask is a flask that just measures out 250 centimetre cubed. That's all it does, and it does so very accurately. So there's a mark on the flask, and when you get up to that mark, when the bottom of the meniscus gets up to that mark, it's reached 250 centimetre cubed. So you add the contents of the weighing bottle to the volumetric flask. Rinse the weighing bottle, because there might be still some residue of solid in there with distilled water, and add that to the volumetric flask. So make sure that it's all washed out of the flask. Dissolve the solid in the water in the volumetric flask by shaking or stirring. So shake or stir to dissolve the solid in the water, and then make up the mark up to the 250 centimetre cubed on the volumetric flask with distilled water. And then at the end you shake the flask to ensure that the solid dissolves and also that the concentration is equal throughout. Calculate the mass in milligrams of propane dioic acid, MR, relative formula mass of 104.0. Need to prepare 250 centimetre cubed of a 0.00500 mole per decimetre cube solution. So what have you got? You've got a volume and a concentration. So the volume and the concentration you can use to work out moles. So concentration is moles divided by volume. Remember, your volume's got to be in decimetre cubed. So concentration is 0.005. Number of moles we don't know. Volume in decimetre cubed, so 250 centimetre cubed. To take it up into a larger unit value of decimetre cubed, you divide by 1000, so 250 divided by 1000 is 0.25. Multiply the two numbers together, so the number of moles is 0.05 multiplied by 0.25, 0.00125. Now moles is mass divided by MR, so we've got the moles is 0.00125 equals mass divided by MR, and you've been given the MR as 104, so multiply those two numbers together. 0.00125 times 104 gives 0.13, but this mass is in grams, so to get it into milligrams, to get grams down to a smaller unit value of milligrams, you multiply by 1000, so 0.13 multiplied by 1000 is 130 milligrams.